Well, my flipping live stream died on me again. I was waffling away to myself. I got the signal, the trigger circuit to work, but I'm getting too much attenuation on it at the moment, so I'm just figuring it out. I think the problem is these filter capacitors seem to be making too much of a difference to the output, and I might actually go for the other IC. So anybody able to see me again, because I've been talking like for an hour and a half, and I don't know, maybe somebody should tell me when my stream stops, because I don't always notice. Yeah, it's kind of annoying talking to myself. I'm getting good at it. I'm practicing like Russ. But yeah, I've got the circuit working, but I'm not happy with it just yet, because I am using a different IC to the one specified in the schematic. But I put two filter capacitors in here, and I had to take one of them out, and it does seem to be, these filter capacitors do seem to be a little bit too nulling. They seem to be snubbing it a little bit too much, so I'm going to look at putting a picofarad value in there, because it seems to be very sensitive. So I'm going to just have a look for a smaller value. The 4.7 nanofarad does seem to be a little bit too much. So I'm going to go for something like a 330 picofarad. So let's try something like that. Right, so I've got 330 picofarad. I'm just going to stick that there a minute so it doesn't fall away and disappear somewhere down a black hole. And I'm going to now, which one did I put? It must have been that one, because the other one's a bit obscured. So let's have a look. Yeah, that's 0.32. So right, I'm going to replace this one. My signal should go wild. Yeah, it's gone pretty big now. So I'm going to stick this one in here instead. I like these capacitors as well, the same leg spacing. It's just to stick this other one up here. Right, so basically the trigger circuit is not going into the trigger input yet, because I want to monitor it for noise. Obviously sticking it straight into the trigger input of the oscilloscope, you're not going to get a reading on the oscilloscope. It's just going to do the trigger drop. So I want to see what's happening on the oscilloscope at the moment, because I'm trying to get this square wave fine-tuned, you know. That's basically what I'm trying to do at the moment. This amp, the op amp, is not quite balanced yet. I think that's the main problem I have right at the moment. The output side seems to work. I can adjust the actual output voltage on there quite well. Maybe this trimmer needs to be, maybe I need to be using that dual, that what do you call it, split rail on the on here as well. I don't know. Let me have a look at the diagram. I don't think it uses. Oh yeah, yeah. So Of course, right. Yeah, these that capacitor needs to go to the centre tap ground rather than the. Yeah, okay, I'll see what I've done wrong here. That needs to go to that floating ground that I created. So this ground needs to go to the floating ground that I made, really. So I'm reading chat anyway, keeping up with Russ, what's happening with Russ and so oh, what's happening with all these live streams? They're all acting up. That might be something to do with the fact that my stream went wacky a bit ago. I don't know if it is live, but no, he's offline. Oh, that spool's getting so big. Right, so I'm going to turn this off because I've got a power switch now. I'm going to reroute, let's see, this chip. I'm going to actually connect this chip to the floating ground, and I should get a more reliable result. I'm going to have to go and get some more black wire because a bit low on it right now. I'll take some off here. My coffee's probably cold. Daughter's just checking in to let me know she's alright, so she says she's still alive and I'll just type lol. Oh well. Sorry I can't show the scope right now, but there's not much to see, it's turned off anyway. I'm just, once I get this sorted out, because it's triangle waveform at the moment and that's no good, it needs to be square. I'm not sure why that is. These are supposed to be these inverters are supposed to be square wave. Why the hell am we getting a triangle waveform coming out? This just doesn't make sense. So it must be the ground that's wrong. This needs to be to this floating split rail ground, so I'm going to disconnect this link, and actually no, it'd be a lot easier if I just disconnect this link from the bottom and create and put a link between there and the split rail so that this whole bottom rail is split. Oh, but then my positive, this lead over here needs to go over here. I think, no, that's output, so no, that can stay on here. That's fine. My positive in is this one, so that's on this side, that's fine. So this goes into my, oh silly me, I'm going to put this, yeah, I'm going to put another, oh, what have we done here? No, that's right, that's right. This wants to go to this one over here. Oh, there's no, I haven't got any holes left. Again, I don't believe it. It's going to have to go in the same hole as that resistor if I can get it in. Might be easy to just poke this in first. I'm going to have to use my tweezers to get it in there, it's tight. Won't go in. If I take the capacitor out a little bit, should be able to get, because those legs are very small, them capacitors, you know. Should be able to share the hole with that one. I think it's going in. Oh, it was, and I pulled it out. I'm going to try the other end, it's a bit longer. It's gone in, good. Right, so I've got a ground, floating ground, which is going to go over that wants to be on this side now. Come on, you bugger. That wants to be on this side. That wants to be in there. So we should have a floating ground now on that IC. So it's going to be running at like half the voltage of the input. So let's see what we have now. Oh, that dimmed quite a lot. So that's floating ground. Might be too much, I don't know. I'll try it again. I'm not seeing any output. Let me just measure the voltages across this chip. It's reading 5 volts now across the chip. It's actually climbing up slowly. So I've got an imbalance now on my split rail. That's it. No, it can't carry the current. That's why. Oh wow, cool. Wow. Oh, oh shit. I went and stood on my lead for my meter and it fell all over the floor. I've nearly broke. You know, my leads are nearly shot. Now, well, they are shot. I'm having to use one old lead that I used like 10 years ago and an existing lead because my other meter leads were completely shot. Anyway, my daughter's buying me new meter leads for Christmas, so yay! That'd be so cool. It'll be so cool to have some decent meter leads for one, because I've been struggling. I used to have some clip-ons a long time ago, but you know, things get lost, things just break and wear out. Oh, cool. Yeah, Magnetron, are you watching my stream? Are you listening at the moment? Oh. Right, okay, cool. Well, we'll figure it out. Yeah, no, it's been a pain. Oh, okay, that's cool. Yeah, it's just that I was talking. I've got this circuit built, and I've got the little switch to turn it on just to test things out, and it's working. But yeah, I've got some slight issues with the balancing it out and everything. It's meant to use a split rail supply. It's meant to. I actually moved the link across to put that on the split rail ground on there, and it's just killed it now. So I'll have to put this back on the. I have to put this back on the actual real ground, cause it was taking too much current, and I've got a 50 milliamp polyfuse in the board here, so I can't technically overload anything because the polyfuse would just trip and cut the power off. I believe in that because it saves you a fortune, especially if you've only got one IC of a particular type. You don't want to be blowing it up. So the polyfuse actually helps to prevent me from overloading it, and it's 50 milliamps this polyfuse. So basically it trips at about 90 milliamps. So let's turn that back on. Oh, I've got no signal coming out now. Have I disconnected something else? Oh, what have I done now? Well, I see what I've done. No, that's right. No, that's not right. Yes, that's wrong. It wants to be across here. It wants to bridge this gap in the breadboard. That's the ground. Right. It should work again now. Yeah, I can see it coming up. I've got a signal again on my scope. I'm testing this. Yeah, but at the moment the trigger circuit is not acting as a trigger circuit. I mean, I mean, if I stick this straight into my trigger on my scope, I can't see the waveform because I want to make sure the waveform's right first. So I'm basically, at the moment, I'm literally just monitoring it as a normal waveform coming out, and to get the waveforms and everything set right before I actually use it as a trigger circuit, because at the moment I've got some little discrepancies with the waveform. It's supposed to be coming out as a square wave, but it's not. It's not. It's coming out triangular, and that shouldn't be. These are supposed to be. Actually, maybe what I need to do is use some of the inverters on the other side to create a latching, to make it latching so that it actually does produce a square waveform. That could be what the problem is. I have got the other IC though. There's two different ICs I've got, and one is an alternative one, and the other one is the proper one. So I might actually swap this out and put the proper one in, because I've actually got the diagram here. It recommends to use the 74HCO4, right? Well, I'm not using that one at the moment. I'm actually using the let's see. I'll take the paper clip out in a minute. If I can get this page open. Oh yeah, it says on this page here. Yeah, this trigger circuit, which is let's see, where is it? So instead of the 74HCO4, which is this here, I'm currently using a CD 4000. Oh no, that's not that one. I'm using a CD 4089. No, 4069. So I'm using a 4069 at the moment. I think that's right. Yeah. So if I don't get the satisfactory results with that, it's fine, because my friend has given me the other one as well. So I actually have both the 74HCO4, and that's a hex inverter, and I also have a CD4069, which is what I put in there for now. So I'm going to actually swap it out in a minute. I think the pinouts are the same. I'll just have a quick look. I think I've got both of them in here. This paper stuck together. Don't you hate that when it does that? Right. So it's on the other page. I printed this out and stuck it in a folder that my mum gave me. I'm also using the LM833N and it's working. I've got the op amp to work, but it's very fussy right now. It needs a little bit, the biasing needs a little bit more finer tuning. I created a dual rail supply, you know, plus 0 volts and minus volts. I created a dual rail supply by using a resistor network. But when I put this in, if I do put this in the oscilloscope, I won't need this dual. So the oscilloscope has already got a split rail supply built into it. So this is just to test this really, and I've got to make sure that the plus volts and the minus volts between the 0 volt is equal. Otherwise, it will be completely out of whack. That's probably what's going on. What I need to do is go and get a Zener diode actually, or a couple of Zener diodes, put them in series with the resistors to help equalize the center voltage. That's another thing I could do. I've got plenty of Zeners, that's for sure. I've got them coming out my ears. Now let's have a look. I still haven't got the right one. Right, this is the CD4069 and the VCC is pin 14, VDD or whatever. VSS is pin 7, and I think I printed out the other one as well. I'm not sure. Maybe I need to go and print the other one out. I don't think I printed it out. Oh, it's in here. Actually, it should be in here. Somewhere. Maybe not. Yeah, that's funny. Oh yeah, actually looking at this, the original diagram, yeah, pin 7 is ground, pin 14 is supply, so that's okay. So it looks like the pinouts are the same. Yeah, based on this diagram, 1 is input, 2 is output, and then 3 is input, and then 4 is output on the next each stage. So it looks like the pinouts are exactly the same for the 74HC04. So I could swap that straight over. But you see, the original circuit is using an AD8561, which is latching. Well, I'm not using a latching op amp. I'm using a linear op amp, so that could be my problem. So what I'm thinking of doing is using two of these inverters, which are on the other side of the chip, to create the latch. That's probably what I should do. So if you use two of the other inverters to create a latch, then it'll basically flip to one way and it'll stay on until the signal comes and flips it back the other way. So it's like a flip-flop, right? So having a flip-flop means that I'll get a steady signal and it'll be a steady trigger pulse. It'll be constant. The thing that you don't want is short pulses that are very small, because that creates inductances, and it's the inductances that can actually cause you to get noise. Having a nice clean square wave produces less problems, because the crowbar effect means when it goes high, stays high longer. You have a much longer duty cycle where it stays high longer and it stays low longer, instead of a quick sharp pulse. And that's when you get instabilities with trigger circuits, when you get a short pulse, because there's deviation and there's more error factors. So the original circuit was using a latching circuit on the op amp side. Well, my op amp is an LM833N, which is good because it's 15 megahertz, but it's not a latching, so I don't have to have the latch there. I can now actually have the latching further down the line, which will still work. So that's something I'm going to look at in a minute. But I've actually got, let me just go and tune my scope a bit. Yeah, I've kind of got a triangle waveform which I don't like. Yeah, it's not the kind of waveform I really want. I'm sorry I can't show that right now, but yeah, if I move the camera around, I'm going to be spending all my time moving cameras backwards and forwards. I can use one camera. I don't have a broadband for two. I've got that to lock. It's very jittery. My flipping copy's gone cold. I keep making copy and forgetting about it. So, you know, I built circuits. I built some circuits in 1983. An automatic light sensor which detects when it gets dark outside and turns my lamp on, and I made that years and years ago, and it still works today. It still works as good today as it did back then. I also built a clapometer thing onto it, so when you clap your hands it would turn the light on and off, but that never worked properly because it was susceptible to fridges turning on and off and spikes down the mains, and it used to trigger by itself, or it didn't trigger when you wanted it to, or you'd clap your hands, it would go on and then go off again. But you see, what I didn't realise at the time when I built that, which was back in the 80s, was that I needed to have, if I'd built it now, what I would do is I would use a long tail type of trigger pulse, whereas you pulsed it triggered a 555, then it waited a few seconds before listening again for another pulse. So what I could have done, you see, I used a flip-flop, right, to trigger the clap thing, so that when you clapped your hands it would turn the light on. So what happened was the relay would click and it would interfere and make a noise, and the noise of the relay clicking would also make it start oscillating. It would start turning on and off by itself, and it was very annoying. And today, thinking about it, if I'd built that today, I would have done it in such a way that it worked, you know, by simply having a listen period where as it was listening, you would clap your hands, it would trigger a 555 timer, the timer would be latched on, it would send another pulse to another circuit which would turn the light on, and then it would basically wait until the 555 timer timed out and then went back into listening mode, so it would have a gap of a few seconds, and it would be immune to further pulses or triggers, so the relay wouldn't actually trigger it again because it would only be allowed to trigger once per 10 seconds or 5 seconds. So I could have built that a much better circuit now. I might even do that sometime actually, because as I say, this circuit I built back in 1983, it works great as a light sensor, and to turn your light on and off automatically when it gets dark outside, it works great, but it's just no good for the clap, you know, when you want to clap your hands to make the light come on and off. That part of it was just really bad. And another thing is, if you got loud music on, it used to trigger all the time, you know, like a disco light. It would flash on and off when your music was playing, and yeah, that was kind of no good, you know. So if I was to do the same thing, I would use a passive filter. I didn't know much about filters back in the 80s. I didn't really mess about with filters too much, to be honest, but there are ways of building a filter now, especially with all these Arduinos. You can do it in software as well. But there is a way of building a high pass and a low pass filter, so that only a certain frequency can get through, so that you can clap your hands, tune it so that it would only detect the clap and nothing else would detect it. It would trigger it. Yeah, that's another way of doing it. To have two pass filters, you had a high pass filter and a low pass filter, and you tune each filter in turn to have a small bandwidth in between of just the frequency that you want to clap your hands to trigger the circuit to trigger on and off. And yeah, that can be easily done. It's very easy to do, but you know, I was younger back in the 80s, and yeah, I was mainly interested in repairing stuff, and I just didn't have the time to work it all that stuff out. And well, the internet has brought a lot more information, a lot more. You can actually, there's online calculators, you can work stuff out, which I didn't have in the 1980s. If you wanted to know something in the 1980s, you had to go to the library and look for tons and tons of books. You didn't have a calculator to work out frequencies and resistor values and all that. You didn't have all that. You got a scientific calculator, and that was it. And I didn't know. You don't know how to use a scientific calculator. If you don't know, you're screwed. So I'm just having to think at the moment, but yeah, there's a video, there's a guy, I used to really like watching his YouTube channels. Oh, the flipping server's gone down again. Oh, what's the matter with this thing? I was just trying to open a text file that's on the server, and I'll turn it on. I was going to get a link to show you, and there's a guy, he's really good. And he was talking about latching, you know, making your inverters latching, you know. I thought, oh, of course, I remember that. You know, I was thinking when I was watching this video, I just happened to be watching it, and I thought, oh my god, yeah, I forgot about that. Yeah, that's it. That's something that you can do. All you need is a resistor from the output of the second inverter that goes back to the first inverter, so that when the first inverter triggers, the inverter feeds back and keeps the other one turned on until another signal comes along that overrides that and turns it the other way. I thought, that's so cool. Anyway, I know how to do it now, and I am going to do that. I'm actually going to build a latch in this chip on the other side, right, so that when the pulse, the output pulse, comes out, it flips, sends a signal to the first inverter. The first inverter goes through the second inverter. No, sorry, the first inverter goes through a resistor back to its input, so it keeps it in that state until another signal comes along and flips it the other way. And it's actually really simple. A very, very simple way of making a latch. You know, it's like a switch. You know, when you send a single pulse in, and it switches and it stays in that state until you send an opposite pulse. You know, like a negative pulse or a positive pulse. Very, very simple, and you get perfect square waves. That's the next stage, right? So I don't even need to look at the diagram because I know how it's done. But it needs to be like 1K or something like that, or a 3K. Actually, I'm just going to find a suitable resistor which I need. Actually, there might be one over here that might work. Oh, my meter's off. Helps if you turn it on. Oh, that's a 1.79k. That was perfect. This will work. This will work. So if I I'm just going to put this aside a minute because I've got to look at the pinouts for the other side. I can't remember the pinouts on the other side. Oh damn it! I pulled my. No, I haven't. I pulled my clip out again. I haven't. Right, the okay, so the latches are the same arrangement after pin 14, so they go the same way, same direction. So all I have to do is send the output of pin 4. Oh, actually no, there's no latch on this side. Oh no, I've got a lot of junk in there. It's getting a bit cluttered, so I'm going to use a latch on the other side, which is easier. So if I send the output of pin 4 to the input or pin 13 and put a resistor between 12 and 13, that would cause it to latch. I think. Anyway, let me just go and double check because I don't want to blow anything up. It's best to double check things. Let me know if my stream dies on you, won't you? Because I can't always tell. Right, oh, I'm just going to get this link up. Oh, there's a bit of a delay getting it, come on. I think my server's still not come up properly. I've been having trouble with my server all day. I think it's because I've been using too much bandwidth or something. Until I have a perfect square wave coming out, there's no point in showing you the scope at the moment because it's basically just a triangular waveform that's coming out. It's not what I want. Right, let me just put this latch. Right, this is a YouTube. Now, take a look at this video that this guy did. It's interesting. I posted it in the chat. Just have a look at that. It's very interesting. I'll actually going to watch it again myself. It's a very useful circuit.
So I thought it could be fun to do a few episodes where I pick some random popular chips and make some circuits with them and see what we can use them for. And today we will take a look at the CMOS 4069 inverter chip.
That's actually what I'm using.
And the CMOS 4069 chip is very simple. It's just 6 individual inverters and it's powered from a positive and a ground. And it can in theory only do one thing. If we put a 1 here, a high voltage, we'll get a low here. And in the other case, if we put a low here, we'll get a high here. And if we tie these two together, if we get a high here, we'll get a high here, and if we have a low here, we'll have a low here.
Very useful little chip.
So that's all great, but inverting signals is not that fun, so we will need to find something else we can use this for. So we can build a latch out of this chip by using 2 of the inverters. and we'll tie those together. And these are powered from the DVD and the VDSS. If we tie the other input and output together with a resistor, we have our latch. And we will put a small light bulb at the output here. And we will add 2 momentary push buttons. One that goes to VDD and one that goes to ground. So now what happens if we press the ground switch? We will set a 0 here, and it will not short out this inverter here because we have this resistor. We will set a 0 here, we get a 1 in the middle, and a 0 here again, and this resistor will also keep this input at 0, so it will.
Hey Alan! Just watching this video.
And after briefly press the VDD, we will set a 1 here, 0 in the middle, and 1 here, and this resistor will also keep this a 1. So when we release the switch, the light bulb will still be on. So now we can try to build this on the breadboard and see if it actually works. And here we have it. So we have the 4069 chip in here. We have the resistor, and we have a current limiting resistor for the LED we will use as a sign to see if it's on or off. And I have my 2 switches. One is connected to ground and the other is connected to plus 9 volts. And you can see right now the LED is off. So if I press the off button, nothing will happen. If I press the on button, it will turn on. And nothing happens if I press it again. And if I press the off button, it will turn off. So that's simply everything it does, but it can be useful for some things. And of course we could make this to be an inverse of what we started with by moving this one to another inverter. And connecting the input of this inverter to the output we were using before. Like that. So now when you press the on button, it will turn off. When you press the off button, it will turn on. Very simple. And we could of course change this LED to a red one. Put another resistor. And put a green LED across the non-inverted output. So now if we press the off button, it's of course red, and when we press the on button, it will change to green. So I don't know if that could be used for anything.
Well, he says he doesn't know if it can be. He says he doesn't know if it can be used for anything. Well, it's used for a lot of things. It's using hi-fi equipment, you know, for turning channel. You can use the same principle with a decade counter as well. To a single button. Every time you press the button, it switches to a different output, and you can actually use it to switch electronic switches. So you can actually have different inputs, like switch from auxiliary to line in to CD. That's what a lot of hi-fis used to do. Actually, used to use chips like that. Very, very common, really. I'm surprised that he didn't mention that, really. But I'm on this other mic. That's probably why. This is a trigger circuit for my oscilloscope. I'm making a trigger circuit at the moment. Oh, did you see the video I sent you, Alan? Actually, I haven't got a reply on the email, so you maybe haven't seen it yet. Yeah, I sent you a couple of emails this morning. My friend made me some 3D prints, but one of them came out a complete disaster, and it was in PLA, and I can't soften it, I can't melt it with acetone to bond it, so but it's something I can hold in my hand at least and visualize it and make measurements and things. It's structurally weak, but it could be bonded with some epoxy, I suppose. It could be repaired with epoxy, but oh, I see. Okay, that's cool. You're travelling. Yeah, that's fine. Yeah. Yeah, I'm on this other camera, and it's got a different microphone, and I'm not sure what the volume. It's probably too loud. Where's my? Oh, no, the volume might be too loud. Let me have a look. It does look a bit loud, actually. Turn it down a bit. That might be a bit better. Oh, you can hear the speaker from the YouTube video, yeah? When I was watching that. Yeah, well, basically, because I'm not using a latching op-amp circuit, which is what I was describing to Magneton, because I'm not using the AD8561, which is latching because it has a latch output on it. Because I'm not using that one, they're about £5 each. They're not cheap. Some of them are actually £10 each. It depends where you go. I need to incorporate a latch, but I'm going to put the latch on the actual. Instead of having the latch on the op-amp side, I'm going to have the latch on the digital chip side. You know. That way I can get a clean square wave. If you look at this image, you'll see that the way it works is you have a signal coming in, which can be triangular, or it could be a short pulse or something, but the output is converted into square wave. Well, at the moment that's not happening because I don't have a latch in here, so it's basically whatever goes in is whatever comes out. So I need a square wave coming out to get a clean trigger signal for the scope. So I'm going to use some of the inverters that are actually on this chip. I'm going to use 2 of the inverters on the other side to create my latch, and then I'm going to test that. And so let's look at this video that is showing now. My inverters. Let's have a look. This is where they are on my chip. And you can see there's 3 inverters on each side. There's 3 on this side, there's 3 on this side. I'm only using 2 inverters on this side, but it's getting a bit cramped down here, so I'm going to leave that inverter alone. I'm going to use the other 2 on the other side where I've got some room, and I'm going to create my latch on this side, and then I'm going to use this side for my output. Obviously there's going to be a phase shift, but that's not going to matter with the trigger circuit. It's the same chip he's discussing actually. No, it's not a 555. It's the 4069. It's the CD4069. That's the output stage. The op amp I'm using is an NE. It's an NE. Where is it? Take that clip out again. It's sorry, an LM833N. It's got 15 megahertz bandwidth. So that particular LM, I don't know if you can see that, but it's got 15 megahertz bandwidth, which was good enough for a 10 megahertz oscilloscope trigger circuit. So, but as I say, if I'd used the proper IC that was in the schematic, it would have a latch built into it. But no, I'm not going to do it. I'm just going to create the latch further downstream, which should be fine. That's what I test out. That's what I want to test out. You see, ideally. So let me just get my clip in because I need to bookmark this so I don't keep losing my page. Oh, and Magnetron has been very kind, Alan. He's sending me a Christmas present by FedEx. And you know what he's sending me? He's sending me a 3D printer. I couldn't believe it. It's just awesome. It's just blown me away. Man, it needs some work, he said. But, and it's I think they're worth, was it £300 or something new or something? Is it a Prusa? I can't remember now. I forgot what it, Alan, sorry, Magnetron can tell you what it is because I've forgotten. Like it's yeah, he has a couple. Yeah, apparently he wants some work doing on the hot end. Well, my friend Richard over here, he can help me sort that out. I think because he's got a mini lathe, so he could do things with making things with hot ends and things. And he's also got a 3D printer, so he could print out stuff for me to make the parts that are missing. If it's a clip or a bracket or something, or we could probably look on eBay, look for parts for it there. So right, so basically, yeah, there's definitely going to be a learning curve, obviously. So I'm gonna, obviously, I want to avoid wasting ABS print material. So I'll be looking for advice on temperature and stuff. And yeah, I'm really terrible. And I still can't draw with 3D graphics. I just can't. But it doesn't matter if I can just get the drawings done. If somebody can help me with those things, and we could send files back and forth and that. I just have to figure it out, and the main thing is if I can figure out how to use the printer. That's the main thing. And yeah. What's that? Cartesian or Delta? I don't know. I don't know what that is. Yeah, it's a hex inverter. Yeah, 4609. I'm not sure what Cartesian or Delta is. Yeah, I honestly don't know much about print. I mean, all I really know about them is what Russ has been talking about, really. Right. Now the oscilloscope at the moment. Let me just move the camera a minute so you can see. The camera. This is basically the oscilloscope. Basically, is just. Oh, where am I? Where is it? Right, you can see it's just triangular right now. Oh, let me get this around this wire. At the moment, I haven't got a square wave, which I need a square wave. Right. That's what it is right now, and it's no good. But we'll sort that out when I put this. When I get this latch built in. And so this is what I need to do at the moment. Oh yeah, I've seen that. It looks similar. It could be similar to that one. Yeah. Well, it actually, maybe Russ has got software which for that printer which you could send me a link. Yeah, well, I'm going to need a lot of help with that. Maybe you could do it over. Maybe you could help me with remote desktop or something. Because remote desktop like TeamViewer or yeah, I've already seen the videos that Russ did, but it didn't show the technical side much. You know, that's the only thing. but maybe somebody with remote desktop could actually help. Because yeah, okay, cool. Yeah, that would be great. I mean, I could live stream the screen and you could tell me what to do and everything. Yeah. Yeah, that could be a way, live streaming it. But you see, at some point, when we get the printer, when it arrives and when I get it working, at some point, I'd really prefer to put the printer in the bedroom on the other computer, because then it could be set running, and it because these prints can take hours, can't they? It can take like 9 hours or something, and it would be better to have it running in a stable temperature environment. The bedroom is very stable. The temperature is very, very stable in there. It's quite warm as well. It's not as drafty as it is in here with doors opening and closing, and the bedroom is somewhere where I could start the print in the morning without having to listen to it all day, and yeah, and just it wouldn't get interrupted that way. It could do its thing. Because you see, having it running on a computer where I'm using the browser and the browser crashes my computer, if I'm using the browser and the computer crashes, I could lose a print. You know, it might be disastrous. So it's better to have a dedicated computer, isn't it? Because I know Russ has said that. Russ has said it's better to use another laptop or something else that is not the main computer to do the print job. So that's probably what I'll have to do. I have got another machine in the bedroom. It can certainly handle that. Yeah. Oh yeah, I can certainly check, no problem. Yeah, a pile of goo is not good, yeah. Right, right, I'm going to press my switch to turn the signal off, and I've got this 1K resistor, which, now if I go back to that video I was watching a minute, the resistor he was talking about goes from the second trigger to the first input, right? And there's a resistor that so I need to put this resistor between here. There's some dust on there. Between there, and get the damn thing in. That's the input, that's the output, and it wants to be between there and there, right? So that 1K resistor is across the input of the first inverter on the other side of the chip, and it's across the output of the second inverter on the other side of the chip. So then I need to connect these two inverters together directly, so I need to link. So I want to get this done so we can see the result. I'm going to pinch this link from over here, put a little bend in it because it needs to be a little bit closer together. I can put it at an angle anyway. Now I'm going to stick this link between the right. So now there's two inverters on this side that are now connected. The output of the second inverter is connected to the input of the next inverter. Then I'm going to use the output from the inverter on this side, which is you know what? I've just realised something. Oh yeah, that's connected. Right, that's the input. Yeah, I just need to work this out a minute. Hang on. Right, that's the input on pin 1, output pin 2, output pin 2 for a resistor, which is the same, like similar to this, but output is going through a resistor to through this. It's going through a filter capacitor as well on this link here. which is to ground. Right, so that filters out noise, and it goes through there. That turns the second one on. Hang on a minute. Input, output, input, output. I have got this in the wrong place. This output lead here should be. No, that's right. Oh God, what am I doing? Input, output, input, output. That's right. It's confusing when you're looking at this. When you're looking at wires everywhere, it's just very confusing. So the output's going across here right now. So I need to take that output that's going to this trimmer port. I need to move that output over to the input of this one here, like that. And I'm going to take my output from this other one. I need another jumper lead. Right, I've got one here. So I need to put this other output. This is hard to see. The legs are just so difficult. Put that input to that trimmer pot there. Across to the output of that one there. That's right. So now with that configuration I should have a square wave coming out, right? But it's going through a capacitor, which means that it's going to be a rise time, you know, thing issue. Okay, I'll just check the chart. Rusty's rolling. Yeah, Rusty's there. Rusty's there, Alan. Yeah, I forgot to mention it. Yeah, Rusty's there. Chat to him while he's here. He's still looking apparently for accommodation. Yeah. Let's all roll. Let's have a rolling party. And I've got a 3, which is better than a duck. Right, okay, so I've got my oh, cool. Right, so now my output is from that stage. So I should have a much squarer waveform now with that resistor there, and this and that input is directly connected right now. But I could put a resistor in there, but you don't have to do. It can drive directly, so that should be fine. So let's see what happens when I turn it on. Oh, actually I didn't see a lot happen then. Oh, it's coming up. Oh wow, it's a lot squarer than it was. Right, let me move my output across to there. Just attenuation on here. Yeah, oh yeah, I'm seeing a slight I'm seeing a dip because it's going through a capacitor, you see. That waveform output is a lot better though. Alright, it's working though. I haven't measured the current to this yet, so I'm going to measure current consumption. Right, I'm going to stick my meter on current. It'll be below 50 milliamps because I've got polyfuse in here. So I want to basically just check current consumption on this circuit. Right, so just do that temporarily. It's consuming 19 milliamps. 20 milliamps. That's good. It's actually very small. So the circuit's only consuming 20 milliamps. Yeah, I think Rusty's definitely excited. Anyway, the waveform is actually better now. I've still got a slight fall time on there. It's not affected by the capacitor, so I'll leave the capacitor in circuit. Now let's just tune that a bit. Oh wow, I get a really... When I turn this up I get a much better output, that's for sure. This probably will be square when... I don't know if this is latching, let's find out. Now if I disconnect this resistor, it should change the waveform. No, it hasn't, so it's not latching properly yet. I probably need to change that resistor. Oh, actually, maybe this link needs to be another resistor. I will actually do that. I'm going to find another resistor for there, and it might improve the latching effectiveness of it. So let's find something like 20k or something, or something like that. I should have some resistors over here. I'm just measuring some because I can't read these. The values are too hard to see. Reading colours on dark background is not easy. I like those white resistors, you know, the cream coloured ones. They're a lot easier to read. What's this one? That's another 1.3k. Actually, I'll put another 1.3k in there. Instead of this wire link going across, no, this one here. Instead of that wire link, I'm going to put a 1.3k between there. I need to turn it off while I'm doing this.